In Algebra 2, section 4.8, we're dealing with quadratic inequalities. Now that you guys are experts at graphing parabolas, so you can use the vertex form, you can use a table, whatever it is that you might want to find, you will now graph inequalities of parabolas. Now, quadratic equations. Now, it's very similar for a line. You're just graphing the parabola like you always do, and then you test either inside the parabola or outside the parabola because you're going to shade one or the other. So, number 1 tells us to graph y is greater than x squared minus 3x plus 2. So I'm going to first ignore the inequality because that doesn't come in until I'm ready to shade. And I'm just going to treat it as an equal sign. Now, I could use the vertex form to find the vertex, to put it in vertex form, but I already know that if I divide this by 2, it's going to give me a decimal, so I don't want to do that. So what I'm going to do is I'm just going to do the negative b over 2a. So negative 3 over 2 times 1, which is 3 over 2. So this is 1.5. That's my axis of symmetry. So right here is my axis of symmetry. And so now I need to plug in this. So to find out what y is, 1.5 squared minus 3 times 1.5 plus 2. So, 1.5 squared is 2.25. 3 times 1.5 minus 4.5 plus 2. So we have 2.25 minus 4.5 plus 2. Negative 0.25. So our vertex is negative 0.25, is positive 1.5, comma negative 0.25. So 1.5, this is my vertex. Now, axis of symmetry, I just need to find a point. I'm going to test a point on this side, so let's try, what is this, half away? 2. So I'm going to do 2, comma, and find my y. So y equals 2 squared minus 3 squared times 2 plus 2. So 4 minus 6 plus 2. 4 minus 6 is negative 2 plus 2 gives me 0. So that goes here. So I have a point 2 comma 0. So that means this is half away. I'm going to find from the axis of symmetry half away and put 0. Okay, so what I did is my first step right here, right? I found my vertex. My second step, I found a point on the parabola, right? And then it copied it, right? My third step is now to test. So I graphed the parabola by finding the vertex. So my first one is graphing. So I found the vertex, and then I found a point, right, to graph. My second step is to then test a point, not on the parabola. So any point that I'm going to try that's not on the parabola, either inside or outside. I can test 0, 0. So because I like testing 0, 0. So I'm going to test 0, 0. So I'm going to put in to original, not on the parabola, original equation. Okay? So right here. So this is x and y. So 0 is greater than 0 squared minus 3 times 0 plus 2. So 0 is bigger than 0 minus 0 plus 2. Is 0 bigger than 2? This is false. My third step is to shade for the true value. Well, here is the point that I tested right here, right? And this is false. So that means everything on the outside of the parabola is false, and I need to shade the ones that are true. I can test the point in here and do all the work, but it has to be one or the other. So process of elimination is if all the outsides are false, then the insides is the one that's true. Okay? So this is false. So I shade the inside because that's true. So any point that I would have tested in here would have been true. Okay? So hopefully that made a little sense. It's probably similar to when we are graphing lines, but the difference is the graphing is a little bit more difficult, and also the shading is inside or outside instead of, on opposite sides of the line. So pause this, go ahead and write it down. We're going to now solve a quadratic inequality, and it's a bit different. Okay, so when we're graphing, steps were solved by graphing. So basically, we're going to be graphing, we're going to find the x-intercepts, we're going to test the x values for the solution, and then we're going to test 3 values, and I'll show you what I mean, and then we're going to shade on the x-axis. So it's a whole new concept, this, okay? Well, it's a combination of things that you've learned, but it's going to be kind of different and weird. So let's just take it one step at a time, right? And by the time to end, you might be able to do some on your own. So the first step is to find the x-intercepts. Now, that means I'm going to ignore the inequality for now. Now I can put it in the quadratic equation, but let's see if I can just put it into 2, because there's no number in front. If there's a number in front, I automatically would do it in the quadratic equation to make it simpler on me, but let's see. 2 numbers when multiplied together gets me 3. So I'm going to take 3, -1, and -3, add up together, -4. Perfect. So -1, -3. So that means my intercepts are x equals +1, and x equals +3. Okay? If you're not sure how to find intercepts using or solving this way, go ahead and look up on the prior videos. But basically, each of these are equal to 0, right? I have to set each of these equal to 0. So if I set this equal to 0, then let me just do it. Because if any of these are 0, then the whole thing is 0. So it's x minus 1 equals 0, and x minus 3 equals 0. And I have to solve for x. So x equals 1 and x equals 3. So that means my intercept is +1 and +3. Okay? It's not important for me to know where the vertex is because I'm not shading necessarily. I'm looking for the solutions here, right? So this is my solution if this was an equal sign, but it's not an equal sign. So it's not asking for me to just graph the inequalities, it's asking for the solution. So we're just focusing on the x-intercept. So what number 2 is asking is for me to then test the values. Okay? So I can have different types. So either everything in between these intercepts, these x's, are true for this, right? Because this is not, there's no x and y. It's not like this one, where I have an x and y. So I'm shading for any values to get me the correct y. This one is when is this inequality true for when it's 0. Now, this doesn't have a line underneath, so what I needed to do was make an open circle, right? So, just a reminder, this is closed, and this is open. So this needs to be open circle. Now, I need to find out where on the x's do my solutions lie. It could be in between here. It could be just this side. It could be just this side also. Okay? So what I'm going to do is I'm going to test an x for each one. So I'm going to test 3 numbers. I'm going to test x equals 0. That's for anything that represents this whole side. I'm going to do x equals 2. That represents in between, to see if any of the in between. And then I'm going to do x equals, well, 1, 2, 4. Okay? So, let's try the first one. X equals 0. I'm going to do it for the original. So, 0 squared minus 4 times 0 plus 3 is less than 0. So 0 minus 0, 3 is less than 0. This is false. Okay, then I'm going to do x equals 2. So 2 squared minus 4 times 2 plus 3 is less than 0. Well, this is 4 minus 8 plus 3 is less than 0. 4 minus 8 is negative 4 plus 3 is less than 0, and negative 1 is less than 0. This is true. False. So this is false. This is true. So that means I know that there's an answer in between, right? Now I'm going to do x equals 4 to see if this side is the solution. 4 squared minus 4 times 4 plus 3 is less than 0. 4 squared, 16, minus 16 plus 3 less than 0. 3 is less than 0. This is false. So that means the only solutions for x, this x value inequality, is just in between. If any of these other were true, I then shade this line and shade this line. I'm not shading entire parts because I'm not focusing on the y's, the points. I'm focusing on only the x values that are true to make this inequality, to make this a 0, right? So I'm only shading in between because that's the only value that was true, was the number I picked in between. That's why we're testing 3 values, and then number 3 is we shaded in. So, hopefully that made some sense. Go ahead and pause this. Write it down. Try 258 numbers 2 and 10, 258 numbers 2 and 10, and I will see you in class.